This tutorial is for T5, write equations of parabolas in vertex form from graphs, for Algebra 2. There are three things we need to remember in order to solve these problems. First, we have two different examples of vertex form. Remember that parabolas can open in four different directions: up, down, left, or right. So when you see a y equals, that's for a parabola opening up or down. We also can recognize it by the x being the value that's squared. To decide if it's opening up or down, we would look at this a. If it's positive, it's opening up. If it's negative, it's opening down. For parabolas opening left and right, we would have an x equals vertex form. Again, you can think of it as the y is the one being squared. If it's opening left, the a would be negative. If it's opening right, the a would be positive. The other thing to keep in mind is our formula for c. If you did flipped math, they called it p. Either way, the c value is the distance between the vertex and the focus, is the same distance between, I was trying to jump down here to number 2, between the vertex and the directrix. So this distance is the same, again, from the vertex to the focus, and the same distance from the vertex to the directrix. So our formula for that is c equals 1 over 4 times the absolute value of a. So we'll be using all three of those and this concept of the distance between the vertex and the focus, or the vertex and the directrix, to solve these problems. So the way these are set up is it's going to give you a graph and ask you to write the equation. So number 1 says the graph shows a parabola and its focus. Write the equation of the parabola in vertex form. So for this graph, what we had was a parabola whose vertex is at 0, 0. So I went ahead and made a note of that. Vertex is at 0, 0. So remember, when we go to write this in vertex form, then our x becomes our h and our y becomes our k, right? So it's important to go ahead and jot a note down that this is your vertex, and so your h value is 0 and your k value is 0. The other thing we learned from this graph is that the focus is at 1, 2, 3, so it's at 3. So the distance between the vertex and the focus is 3. Alright, now that we know those things, we can start plugging in numbers to this formula. So we said c was the distance between the vertex and focus. We counted that and saw that it was 3. So we plug in 3 for c, and then the rest we just bring on down. We copy it down. So 1 divided by 4 multiplied by the absolute value of a. Now this, remember, is where it gets a little weird. You're going to multiply by the denominator, and you're going to do that to both sides. So to get 1 by itself over here, you would multiply all of this by 4 times the absolute value of a. What you do to one side in algebra, remember, you do to the other side. My equals sign is a little light there, but you're going to do it to the other side of the equals sign. So you have 4 times the absolute value of a times 3. So we can simplify that as 12 times the absolute value of a equals, and then that canceled all of my 4 times the absolute value of a out. So I'm just left with 1 on this side. Now, I can still use my principles of algebra to get a by itself. I would divide both sides by 12, which leaves me with 1/12 on the right. Now pause for a second here and think about this. It's totally fine to have a fraction, because your a value here is almost like what we would talk about with our m value for slope. So it's going to tell us how far to rise and how far to run. So a fraction here should not be unusual. But whenever we're talking about absolute value, it could be plus or minus. So to decide if it's a positive 1/12 or a negative 1/12, we glance back at our graph and we see that our parabola opens up. Remember, if it opens up, your a is going to be positive. So I can rewrite this as just 1/12. I can do away with the plus or minus because now I know that it's positive. So we used our c equals 1 divided by 4 times the absolute value of a to solve for our dilation factor of a. So we plugged in our C, our distance between the vertex and the focus, and we solved for A. And A is that value that we need to know here to put at the beginning, right? So now that we have our vertex and we have our A value, I can rewrite our vertex form just like that shell, right? So when I do that, I need to make sure it's the y equals version of the vertex form, because this is a parabola that opens up or down. So in this case, up. So I'm just going to copy all of my formula down from up here and not plug in anything. You can go ahead and combine some steps if you want, but I like to rewrite that formula because I know it's going to help me get all these things in the right places, but it's also going to help me commit this formula to memory, because if I have to write it every time for every problem, then it's going to start sticking in my brain. So I rewrote my formula for the y equals because we have a parabola that's opening up, and then I just start plugging in my three values. So for A, I plug in 1/12. For H, I plug in 0. For K, I plug in 0. So now we already know that 0, we don't even have to write it, but I like this second step. So I plug everything in. So I'm not losing this habit of doing the second step, because remember, this would get like a flipped sign in here if you're just trying to combine too many steps and jump to the final line. So I like to do this in-between section where all I'm doing is plugging in my A, my H, and my K. So once I've done that, then I can clean it up. I know that x minus 0 is just x by itself. So I can say 1/12 x squared, because I can't forget my squared there. And then if I had something else over here, like a +3 or a -7, I would include it. But since this was a 0, then all I have to do is end it there. So our equation for this parabola, for this graph, is y equals 1/12 x squared. So let's look at another example, number 2. I didn't copy down the words, the directions for this, but it's the same thing. So we have a graph of a parabola, and then we need to write the equation for that. Now in the last one, we could see the vertex and the focus. This time we can see the vertex and then the directrix. So remember that either one of these, we can get that same value of C, because we're concerned with the distance between the vertex and the focus. So even though it's not labeled, I could go ahead and tell you that the focus for this is right here, because if this value was 1, it would be 1 in the other direction to get to my focus. So whichever one they give us, we can still get that C value from there. So the first thing I like to do is write down my vertex. I saw that it was 0, 7. So remember, this is our x and this is our y. I like to go ahead and come over here to the side and identify my H and my K. So when I'm plugging those numbers back in later, I already know what those two are. I don't have to go back and risk mixing up my H and my K. The next thing I do is I solve for A by plugging in the value of C. So C, remember, is the distance between the vertex and the focus, but it's also the distance between the vertex and the directrix. So since this was 1, then I would just plug in a 1 here. Remember, we multiply then by our denominator. So 4 times the absolute value of A times 1 would just be 4 on the absolute value of A. And then that leaves us with 1 on the right side. We divide both sides by 4, leaving us with A, or the absolute value of A. 1/4 is what we would get here, and then we have to decide plus or minus. Since this parabola opens down, it's going to be negative. So A equals -1/4. You can remember this again by thinking of slope. If you had a line that was going down, then your slope M would be negative, right? So the fact that it's opening down would mean that this would be negative. So now we have our three values. We have our H, our K, and our A. Once we have that, we can copy down whichever form of the vertex form we need, either y equals or x equals. This is an example of a parabola that opens up or down, and in fact down. So we're still going to use our y equals. So again, I like to copy that down without plugging anything in to commit this formula to memory, and also to make sure I don't miss anything by combining too many steps. Now I just plug in my three values. For a, I plug in -1/4. For h, I plug in 0. And for k, I plug in 7. Once I've plugged all three of those in, I see if there's anything I can clean up. So I know that -0 won't affect that x, so I can just take that out. So now I have y equals -1/4 x squared plus 7. Alright, so let's look at a few more examples because these have quite a few different steps for you. So in example number 3, we have a parabola that's opening down. From the graph, we can see the vertex, and they also have the focus labeled for us. So that's how we'll get our value of c, that distance between the vertex and the focus. Again, the first thing I like to write down is the vertex so I can get my h and my k. The vertex here is 0, 6. So my h is 0 and my k is 6. Then I find I have to solve for a, the dilation factor, by plugging in c. c is that distance again between the vertex and the focus, or if they had given us the directrix, it would have been that distance. So either way, it's the same number. Here we can see 1, 2, 3, that's our distance. And then we just multiply by the denominator. So think about multiplying these two numbers here. So 3 times 4, 12a. And for the purpose of this tutorial, I'm going to quit saying absolute value of a because it's a mouthful. So 12a equals, and that just left us with 1 here. So once I divide both sides by 12, I get a equals 1/12. Since it was absolute value, it could be plus or minus. The way I figure out which one it is to see which way this parabola opens. Since it opens down, it's going to be negative. So -1/12. Then I can plug in my three values, a, h, and k, into my original vertex form. A is -1/12, h is 0, and k is 6. Then I clean it up by taking out that -0. My final answer then is y equals -1/12 x squared plus 6. Alright, let's look at a couple more. Number 4. We have a parabola that opens up. We can tell from the graph where the vertex is, and we also have our directrix labeled. So to get c, we're going to look at the distance between the vertex and the directrix. The first thing I'll label over here to the side is the vertex is 0, -5, which gives me my h value and my k value. I have to use c then to find my third value, my a. So we see the distance 1, 2, 3, 4. So I plug in 4 for my c. Then I multiply both sides by 4a. So 4 times 4 is 16. So 16a equals 1. I divide both sides by 16. A equals 1/16. Since it was absolute value, it could be plus or minus. So we check which way it's opening. It's opening up, so it's a positive. So a equals 1/16. Now I just plug in my three values here in my original shell. So 1/16 times x minus h squared minus 5. And since this was a negative, it had to be a -5 here. And then I try to simplify it, clean it up a bit. That 0 doesn't mean anything, so I can leave it at y equals 1/16 x squared minus 5. Just a couple more. Number 5. We have a parabola opening up. We can tell the vertex and the focus from the graph. I write down my vertex. From there I can get my h and my k values. I use the distance between the vertex and the focus, 1, 2, to solve for a. So I plug in 2 for c, multiply both sides by 4a, leaving me with 8a equals 1. A equals 1/8 after I divide both sides by 8. It could be positive or negative since it was absolute value. I check to see which way the parabola is opening. Since it's up, it's positive. Then I go back to my shell and I plug in 1/8, 0, and -2 for a, h, and k. I clean it up by taking out that 0, and the equation for this parabola then is y equals 1/8 x squared minus 2. 4 more and we're done. Number 6, we have a parabola opening up. From the graph, I can see the vertex and the focus. I label my vertex over here, which gives me h and k. I find the value of c, that distance, so 1, 2, 3, 4, 5. So I plug in 5 here. I multiply both sides by 4a, giving me 20a on the left and leaving me with just the 1 on the right. Divide both sides by 20 to get a by itself. A equals 1/20. It could be positive or negative, so I check which way it's opening. Since it's up, it's positive. Then I plug in my a, my h, and my k here, and I did start combining steps. I didn't rewrite that shell since this was our 6th problem. So 1/20 x minus 0 squared plus 1. The minus 0 is not doing us any favors, so we can take it out. So y equals 1/20 x squared plus 1. Number 7. From the graph, we can see our vertex and our focus. I write down my vertex, giving me h and k. I plug in my value for c, which was 1, and then I solve for a for 1/4. So then my equation here would be 1/4 x squared minus 7. So again, I started combining some steps once we got through a lot of those practice problems. Let's look at number 8. This is our first and only example in these 9 equations, or these 9 graphs, of one that opens left or right. So number 8, from this graph we can see that the parabola is opening to the left. Our vertex is here. Our focus is here. I would copy down my vertex. Remember, this is the x and the y value. So it was over 4 and up or down none. So 4 is 0, giving me my h and my k values. I can still use my graph to find that c, that distance. Here it's 1, 2 between the vertex and the focus. So I plug in 2 here, solve for a, which is negative 1/8. Now this time, remember, since we have a graph that's opening left or right, we're going to use that x equals version of the vertex form. So x equals negative 1/8 y minus 0. So remember, when it's the x equals, this is where your y goes and this is where your k goes. And then your h goes out here. So once I clean that up and take the 0 out, x equals negative 1/8 y squared plus 4. Alright, last example. Number 9, a parabola opening down. We have our vertex, and we can see our directrix here above it. Our vertex is at 0, 0. The distance between the vertex and the directrix is 4. So we use that to solve for a, negative 1/16. Since there was 0h and 0k, our final answer for this one looks like y equals negative 1/16 x squared.